Hiya! Today we are going to look at a beautiful question from AEA 2012. This question combines series with trigonometric functions and identities. Without any further ado, let's get started. Part A. We want to show that tan of theta is equal to 3 to the p. Now, be very careful with this. The typical strategy when dealing with unknown questions like this is to refer to sine and cos. This is not a bad strategy. However, it can cost you a lot of time. The second option is to try to express everything in powers of tan theta. And it's the latter path that I would like to solve the question. Let's look at the left-hand side. Tan theta, tan 2 theta. Tan 2 theta is 2 tan theta divided by 1 minus tan squared of theta. This will give you the left-hand side in powers of tan theta. Look at the right-hand side. The right-hand side is a geometric series. The first term is cosine of 2 theta to the 0. The common ratio is cos of 2 theta. I do not want the 1 hanging out over here. So I am going to use an appropriate double identity for cosine to get rid of the 1 in the denominator. I am going to use the 1 minus 2 sine squared theta. And this simplifies your answer to 1 divided by sine squared theta. 1 divided by sine squared of theta is cosecant of theta squared. Cosecant squared is equal to cotangent squared plus 1 using your Pythag identities. Cosecant is 1 divided by tangent. So I can further express this as 1 divided by tan squared plus 1, or tan squared plus 1 divided by tan squared. Now we can equate the left-hand side with the right-hand side. We have successfully expressed both sides in powers of tan theta. So 2 tan squared divided by 1 minus tan squared is equal to tan squared minus 1 plus 1 divided by tan squared. 2 tan to the 4 is equal to 1 minus tan to the 4. 3 tan to the 4 is equal to 1. Tan to the 4 is equal to 1 over 3. And therefore, tan of theta is equal to plus or minus the fourth root of 1 by 3, or plus or minus 3 to the power of negative 1 by 4. Where do we go from here? Go back to our domain. We are given that theta is between 0 and pi by 2. On this interval, tan theta is strictly positive. When in doubt, sketch it out. The sketch does not have to be accurate. You just need to get the behavior of the function from this. Therefore, look at the sketch. We deduce that we have to reject the negative root. So tan theta is equal to 3 to the power of negative 1 by 4. In part B, we want to show that pi by 6 is less than theta is less than pi by 4. This means that our root must lie between pi by 6 and pi by 4. However, as y equals to tan of x is monotonically increasing, this also means that our value is right between tan of pi by 6 and tan of pi by 4. tan of pi by 6 is equal to root 3 by 3. Tan of pi by 4 is equal to 1. Therefore, we can start our proof with 1 is greater than 3 to the power of negative 1 by 4, greater than 3 to the power of negative 1 by 2. Therefore, tan of pi by 4 is greater than tan of theta is greater than tan of pi by 6. Looking at the graph, tan of x is monotonically increasing on this interval. Therefore, pi by 6 is less than theta is less than pi by 4. As this is a 2-mark question, they're not expecting a lot of explanation. Use the number of marks to your advantage. Adjust the right amount of explanation.